Hello all, welcome to Unacademy. Today we will going to see our next chapter from linear algebra, that is eigenvalues and eigenvector. It is totally related with the previous two chapters, that is we have seen matrices, how to find out the rank of a matrix, and that is very important for this chapter. If you don't understand it, then go through my previous video for the matrices and see how we learned how to find out the rank of a matrices. Now see, in this topic we will see in this topic we will see in linear algebra how to find out the eigenvalues and eigenvectors. Okay, I will tell you about each and every point, how to calculate the eigenvalues and eigenvectors, if the matrix is symmetric and if the matrix is asymmetric, how to find out the eigenvalues for the repeated eigenvalues, how to find out the eigenvectors for the repeated eigenvalues, and how to find out the eigenvectors for the not repeated eigenvalues if the matrix is given symmetric matrix or asymmetric matrix. Okay, so let's start. First of all, going to start this, let me introduce myself. Myself, Dhanashree Palasdeokar. I completed my MSc in Mathematics from Mumbai University. I'm having 13 plus years of teaching experience, and I also mentored more than 10,000 plus students for the engineering. Now, before going to start our actual topic, let me give a brief how to install the Unacademy's learning app. So first step is go to your Unacademy's learning app and then type Unacademy's learning app and then install the Unacademy's learning app. Press the button install so that your app get installed, and then after that you have to manage your goal. It means for which course you want to study, that you have to manage your, see there are many courses available on the Unacademy's learning app, so you have to manage your just like we are managing our goal GATE and ESE. After that you have to choose the courses. If you want to purchase of free classes, free courses, special classes, plus courses, anything you can choose here. Now after that you will take a get subscription button, press the get subscription button, so you will be the part of India's largest learning platform with the top educators. Okay, and after that the best important thing I will going to tell you here, if you want a 10% subscription on your subscription fees, then you can use my promo code, that is DSP. Okay, after using this promo code you will get a 10% subscription of your fees. So see here, you will get this type of, and you can pay any method by any method you can use to pay the Unacademy subscription fee, like debit card hai, EMI hai, UPI hai, wallets hai, net banking hai, anything you can use it here. Okay, now let's start our first topic, that is eigenvalues and eigenvectors. Okay, first of all, what you mean by eigenvalues and eigenvectors, that we will see. See, if A is a square matrix, then the characteristic polynomial of A is determinant of A minus lambda I, and the characteristic equation is determinant of A minus lambda I into X. Okay, determinant of A minus I into X. Actually, here is X. Determinant of A minus lambda I into X is equal to 0, where A is equal to, so this is our characteristic equation, A minus lambda I into X is equal to 0. Okay, now see next, if matrix is in the form of A11, A12, A1n, A21, A22 up to A2n, AN1, AN2, ANn, then your determinant matrix is here A minus lambda I is the matrix, here A11 minus lambda 1 and lambda 2, lambda 3 up to lambda n. Okay, here lambda 1, lambda 2 up to lambda n. Okay, so you will get this matrix. Now the roots of these characteristic equations are the eigenvalues or characteristic root or latent root. These roots of this characteristic equation is known as the eigenvalues or characteristic roots or latent roots. Any word can be used, but generally most of the time we will use eigenvalues or characteristic roots. Okay, now see, for this, for solving such type of example, you must have to know the synthetic division also. Okay, now first of all, this is the first character C. These characters are very important while solving the examples of eigenvalues and eigenvectors. See, once you know these all 7 plus more characters here, okay, so if you know these characteristic properties, then definitely you can solve any example on eigenvalues and eigenvectors. Okay, if A is a square matrix of order 3, then determinant of A minus lambda I is equal to 0, and you will get the characteristic equation is this: lambda cube minus s1 lambda square plus s2 lambda minus determinant of A is equal to 0. Okay, if your square matrix of order 3, that is 3 by 3 matrix, then definitely you will get the characteristic equation is lambda cube minus s1 lambda square plus s2 lambda minus determinant of lambda is equal to 0. Now what do you mean by S1? S1 is the sum of minors of order 1 along with the principal diagonal elements, that is A11, A22, A33. Suppose your matrix is like this, the matrix of order 3 by 3, A12, A13, A21, A22, A23, A31, A32, A33. Now this is your matrix of order 3 by 3. Then definitely the sum S1 is the sum of all the principal diagonal elements. Okay, so here we can write S1 is equal to A11 plus A22 plus A33. Okay, what do you mean by S2? S2 is equal to the sum of the minors of order 2 of the along the principal diagonal elements. It means here we can write S2 is equal to, see, I can write here S2 is equal to A11 into determinant of A22, A23, A32, A33, okay, minus A12, sorry, plus here A12 into determinant of A21, A23, A31, A33 plus A13 into A21, A22, A31, A32. Okay, so you can calculate S2 by using this formula. Okay, so S1 and S2. Now here lambda, determinant of A, here determinant of A, we can calculate. Now we know how to calculate the determinant of A here. So using by these values, you will get the characteristic equation. Okay, now spectrum of the matrix is a set of eigenvalues. So whatever eigenvalues are there, suppose this is your 3 by 3 matrix, so there are 3 eigenvalues. So lambda 1, lambda 2, lambda 3. This is called as a spectrum of a matrix. Okay, now the trace of a square matrix is the sum of its diagonal elements. That is, trace of matrix A is equal to A11 plus A22 plus A33. Okay, so once you, if the matrix is given and the question is asking that find out the trace of the matrix A, then directly you can find out the matrix trace of a matrix A is A11 plus A22 plus A33. Okay, now the next point is the largest of the absolute values of the eigenvalues of A is called the spectral radius of A. Whatever the largest eigenvalues of A, that is the spectral radius of A. Now, if lambda is the eigenvalue of the matrix A, then the matrix A minus lambda is a singular. A minus lambda I is a singular. The degree of the matrix, the degree of the characteristic equation of matrix A is equal to the order of the matrix. Okay. Now, eigenvalues of a diagonal matrix, upper triangular matrix, lower triangular matrix are the diagonal elements. Okay. Now, for example, suppose here diagonal matrix. So, diagonal matrix is 2 0 0 0 1 0 0 0 5. Okay. Then eigenvalues are lambda is equal to 2 1 5. What are the eigenvalues? Eigenvalues are lambda is equal to 2 1 5. So, you will get upper triangular matrix. So, this is our diagonal matrix. So, diagonal entries are 2 1 5. So here diagonal matrix are, eigenvalues are 2, lambda is equal to 2 and 5. Now upper triangular matrix. So what do you mean by upper triangular matrix? Here upper triangular matrix is like this. Okay, so the diagonal eigenvalues of this matrix are 1, 3, 2. Directly we can write out the eigenvalues are lambda is equal to 1, 3, 2. Now lower triangular matrix. So what do you mean by lower triangular matrix? Here, see the upper entries are 0. So this is your lower triangular matrix. So eigenvalues are lambda is equal to 2, 5, 4. Now see the properties of eigenvalues. So what are the properties of eigenvalues? Now the sum of the eigenvalues of a matrix is the sum of the elements of the principal diagonal. Okay, the sum of the eigenvalues of a matrix is the sum of the elements of the diagonal principal diagonal elements. So here this property is very important while finding out the eigenvalues for the given matrix in the MCQs. Okay, so lambda 1 plus lambda 2 up to lambda n is equal to a11 plus a22 plus ann, and second one, the product of the eigenvalues of a matrix A is equal to its determinant. Okay, so determinant of A, with the help of eigenvalues you can directly calculate. Determinant of A is equal to lambda 1 into lambda 2 into lambda 3 up to lambda n. Okay, third property, if lambda is the eigenvalue of the orthogonal matrix. Now in yesterday's lecture we have seen, last lecture, what you mean by orthogonal. I already told you about the orthogonal transformation. If you don't know, you can go through my channel and you can search orthogonal matrix. So definitely you will get it. So orthogonal matrix, it means A into A transpose is equal to identity. Okay, now suppose A is the orthogonal matrix of A, then 1 upon, if lambda is the eigenvalue of an orthogonal matrix A, then 1 upon lambda is the eigenvalue of A inverse. Okay, now if lambda is the eigenvalue of an orthogonal matrix A, then 1 upon lambda is also a eigenvalue. Now, if lambda 1 up to lambda n are the eigenvalues of matrix A, then A raised to m has the eigenvalues lambda 1 raised to m, lambda 2 raised to m, and so on, lambda n raised to m. M being a positive integer. Now see, a square matrix A and its transpose A transpose, see here transpose, have same eigenvalues. Okay, so if lambda 1, lambda 2 up to lambda n are given values of matrix A, then the eigenvalues of matrix K into A are K into lambda 1, K into lambda 2 plus and so on, sorry, not so on, plus and so on, K into lambda n. K is the scalar and non-zero. Okay, now if lambda 1, lambda 2 up to lambda n are the given values of matrix A, then the eigenvalues of matrix A are plus or minus ki, lambda 1 plus k plus or minus k, lambda 1 plus or lambda 2 plus or minus k plus and so on, lambda n plus or minus k, where k is the scalar and non-zero. Okay, now next one. Now see, if the matrix is given matrix A is like this, the characteristic equation determinant of A minus lambda I is equal to 0. Okay. Now the characteristic equation determinant of A minus lambda I is equal to 0. So eigenvalues is equal to roots of this equation. So what are the eigenvalues? Eigenvalues are the roots of this equations. Okay, so eigenvector x is equal to xyz. Now eigenvectors you can find out for there are two types of eigenvectors. First is non-repeated eigenvalues and for repeated eigenvalues. Now for non-repeated eigenvalues vectors, for different eigenvalues of lambda, we will solve A minus lambda I into x is equal to 0 gives the eigenvectors. Okay, now for the rank of a matrix A minus lambda I, that is R n minus, then there are n minus R eigenvectors are possible, where n is the number of unknowns. Suppose rank is 1, then there are matrices of order and matrix are having 3 unknowns. So you will get there are 3 minus 1, it means 2 eigenvectors. Okay, so if one eigenvector only possible, then find it easily. Now if there are 2 vectors, then we have to check out whether it is A is not equal to A transpose. It gives only one equation, put z is equal to 0 and find x and y, and put y is equal to 0 and find x and z. Okay, if A is equal to A transpose, okay, if A is equal to A transpose, then matrix symmetric and asymmetric. Depending upon that, now if A is not equal to A transpose, it means for a symmetric matrix we will use this, and for symmetric matrix we will use this. Okay, find a one and if A is equal to A transpose, find one matrix one eigenvector and consider the other eigenvector x3 is equal to element transpose, that is x3 is equal to column matrix element, and solve x1 into x3 transpose and x2 into x3 transpose, which is equal to 0. Now find the value of LMN. Okay, now see the first example, how to calculate the eigenvalues and eigenvector. Okay, find the eigenvalues and eigenvector for the given matrix. It's a simple example. We'll start with the simple example, how to find out the eigenvalues and eigenvectors of the given matrix, which is 2 by 2 matrix. Okay, now just see, first of all consider, see given matrix A is equal to, the characteristic equation is, okay, the characteristic equation is determinant of A minus lambda I, so which is equal to determinant of A is 14 minus 10, 5 minus 1, okay, minus lambda I. First we will write down here directly 14 minus lambda I. So here 1 2 by 2 identity matrix is 1 0 0 1. So you will get 14 minus lambda, and here is minus 10, 5 and minus 1 minus lambda, okay, is equal to 0. Now calculate the determinant of this, 14 minus lambda into 1 minus lambda, bracket square, minus of minus 50 is equal to 0. So we'll get the characteristic equation, minus 14 lambda minus plus lambda, okay, minus plus lambda minus lambda square minus plus 50 is equal to 0. Okay, so you will get minus lambda square minus 13 lambda plus 36. See, minus lambda square minus 14 lambda plus lambda minus 13 lambda. Okay, now see, minus 13 lambda, and here is 50 minus 14, that is 50 minus 14, it means 36. Okay, so here is minus 36 plus 50 plus 36 is equal to 0. Okay, so you will get minus 14 lambda minus plus lambda, the minus plus lambda square. Okay, so you will get here plus lambda square minus 36 minus 13 lambda plus 36 is equal to 0. So therefore the characteristic roots are minus 9 lambda minus 4 lambda plus 36 is equal to 0. So lambda into bracket lambda minus 9 minus 4 into bracket lambda minus 9 is equal to 0. So lambda minus 9 into lambda minus 4 is equal to 0. So lambda is equal to 9, lambda is equal to 4. Okay, these are the eigenvalues for the given matrix. Okay, now we will find out the eigenvectors for the corresponding eigenvalues. Now we will consider A minus Consider a minus lambda I into x is equal to 0, right? So for the eigenvalues 14 minus lambda, then minus 10, 5, minus 1, minus lambda into x we can write xy is equal to 0, 0. Okay, so we will get the equation for lambda is equal to 4. For lambda 1 is equal to 4, we will take for lambda 1 is equal to 4. Okay, for lambda 1 is equal to 4, so we will get 14 minus 4, that is 10, then minus 10, minus 5, and minus 4, minus 5. Here is 5 only, and here you will get minus 5. Okay, into xy is equal to 0, 0. So we will get the system of equations 10x minus 10y is equal to 0, 5x minus 5y is equal to 0. Now if you observe, the vectors are same, so both are giving the same, that is x is equal to y. Okay, so we can take the first eigenvector for eigenvalue. For eigenvalue, lambda is equal to 4, eigenvector x1 is equal to, if I put x is equal to 1, then y is equal to also 1. So eigenvector 1, 1. Okay. Now similarly you can calculate for the eigenvalue. For eigenvalue lambda 2 is equal to 9. So you will get 14 minus 9, that is 5. Now just put the value of lambda here. 14 minus 9, that is 5, minus 10, 5. Means minus 10, 5. And then minus 1, minus 9, minus 10. Again you are getting the same equation. Xy is equal to 0, 0. So from this matrix we are getting 5x minus 10y is equal to 0, and again 5x minus 10y is equal to 0. So which implies 5x is equal to 10y. Okay, so x is equal to 2y. So we will get the x2 eigenvector for lambda 1 is equal to 2. The eigenvector is x2 is equal to 2, 1. For lambda 2 is equal to 9. Okay, so these are the eigenvectors corresponding to the eigenvalues lambda 1 and lambda 2. Okay, now next example. The next example 2. Find the eigenvalues and eigenvalues and corresponding to eigenvectors for the given matrix. Now it's a 3 by 3 matrix. As I told you, for the 3 by 3 matrix, first we will calculate the determinant of A, and the characteristic equation is given by the formula lambda 1 cube minus lambda 1 s1 lambda square plus s2 lambda minus determinant of A. So we will calculate determinant of A first. So 4 into bracket 3 minus 8 minus 2 into bracket minus 5 minus of minus 4 minus 2 into bracket minus 20 minus of minus 6. Okay, so which is equal to 3 minus 8 minus 5 into 4 minus 20 minus 4 minus 5 minus of minus is plus 4. So minus 1 into minus 2, so plus 2 minus 20 minus minus plus 6, so minus 14 into minus 2, so plus 28. So you will get 30 minus 20. So determinant of A is equal to 10. Okay. So we are getting determinant of A is equal to 10. Now once we get the determinant of A is equal to 10, then what we will get? If the determinant of A is equal to 10, then calculate the characteristic equation is lambda cube minus s1 lambda square minus plus s2 lambda plus s2 lambda minus determinant of A is equal to 0. Now we will calculate s1. So what is our s1? We determinant of A we already calculated. Now what is s1? s1 is the sum of a11 plus a22, a11 plus a22 plus a33, that is here 4 plus 3 plus 1, that is 8. So s1 is equal to 8. Okay. Now what is s2? I will calculate S2. So first we will write out A here. The values of A are 4 2 minus 2, 4 2 minus 2, minus 5 3 2, minus 5 3 2, minus 2 4 1, minus 2 4 1. Okay, so we'll calculate S2. S2 is equal to the sum of the minors of A11, A22 and of order 6. Okay, so determinant of A, that is 3 2, minor of order. So 3241 plus determinant of second column 4 minus 2 1 plus determinant of 4 2 minus 5 3. Okay, so you will get 3 minus 8 plus 4 minus 4 plus 12 plus 10, which is equal to minus 5 plus 0 plus 22. So you'll get 17. So S2 is equal to 17. Right? So we can write S2 is equal to 17. S1 now we get determinant of A is equal to 10. S1 is equal to 8. S2 is equal to 17. So the characteristic, therefore characteristic equation is lambda cube minus s1 lambda square plus s2 lambda minus determinant of A is equal to 0. So lambda cube minus s1 is 8, 8 lambda square plus 17 lambda minus 10 is equal to 0. Now here is the our most important job to find out the eigenvalues. It means the characteristic roots of this equation. So we can calculate the characteristic roots of this equation. So we will calculate the characteristic roots of this equations are, now see, first one we will check we will calculate this by using the synthetic division. Okay, we will check whether one is the root of this characteristic equation or not first. So while putting lambda is equal to 1, so 1 minus 8 plus 17 minus 10. So minus 10 plus 18 minus 18, it will gives you 0. Okay, so therefore lambda is equal to 1. Okay. Therefore, lambda is equal to 1 is the first root. Is the first root of characteristic equation. Okay. Is the first root of characteristic equation. Now, see. So you will get lambda cube minus 8 lambda square. Lambda cube minus 8 lambda square plus 17 lambda plus 17 lambda minus 10 is equal to 0. So lambda is equal to 1. So use the synthetic division. So synthetic division 1 here. 1 minus 8, 17 minus 10. Okay. So keep 1 as it is. So 1 into 1 here 1. You know the synthetic division, how to calculate the roots by using synthetic division. So minus 1 plus 8 minus 7. Minus 7 into 1 minus 7. So we'll minus 17 minus 7 is 10. So 10 into 1 is 10. So again here is 0. Okay. So minus 10 plus 10 is equal to 0. So we will get lambda's the first root lambda minus 1 into lambda square. Here coefficient of lambda square is 1. Okay. Lambda square minus 7 lambda square minus 7 lambda plus 10 is equal to 0. Now we can find out the other roots for this. So we'll get lambda minus 1 into here the roots are, so lambda square minus 5 lambda minus 2 lambda plus 10 is equal to 0. So we will get lambda minus 1 into lambda minus 5 into lambda minus 5 minus 2 into lambda minus 5 is equal to 0. So lambda minus 1 into lambda minus 5 into lambda minus 2 is equal to 0. Okay. Lambda minus 5, lambda minus 1 into lambda minus 5 into lambda minus 2 is equal to 0. Okay. Now therefore the roots of these equations are lambda is equal to 1, lambda is equal to 5 and lambda is equal to 2. Okay. The roots are distinct. All the roots are distinct, not repeated. Okay, so for each eigenvalue, so these are the eigenvalues. So these are the eigenvalues for the characteristic equation. These are the eigenvalues for the given matrix. Okay, for the given matrix. Now, these are the roots of the eigenvalues for the given matrix. Now, we will find out, now for every eigenvalue, we will find out the corresponding eigenvector. Okay, now this is the, see, if you observe here, this is a symmetric matrix. 4 2 minus 2 4 minus 5 2, now minus 5 3 2 2 3 4. This is a symmetric matrix. So we will go to our chart. See, in this chart non-repeated eigenvalues, then for different eigenvalues we will get different eigenvectors. Okay, so we will find out the different eigenvectors for the different eigenvalues. Okay, now see, now for lambda is equal to 1, for eigenvalue lambda is equal to 1. We will find out the eigenvector. Consider a minus lambda I into x is equal to 0. Okay. So your a is a minus lambda I. It means you will get 4 minus lambda 2 minus 2, then minus 5 3 minus lambda 2, then minus 2 4 1 into eigenvector xyz is equal to 0 0 0. Okay, now 4 minus lambda into this. So we will get the for lambda is equal to 1, for lambda 1 is equal to 1. Now we will call this as equation star. Okay. So whatever eigenvalues are there, we will put it in the star. So for lambda 1 is equal to 1, we will get the matrix 3, 2, minus 2, minus 5, 2, 2, minus 2, 4, 1 minus lambda. Okay. So here lambda is equal to 1, so 0. So x, y, z is equal to 0, 0, 0. Right? Now we will find out 3x. Now system of equations you will get 3x plus 2y minus 2z is equal to 0. 5 minus 5x plus 2y plus 2z is equal to 0. Now minus 2x plus 4y plus 0z is equal to 0. Okay. So we can find out the value of x, y, z by using Cramer's rule. Okay. So we will get x upon determinant of, see, we'll use this equation. So 2240 which is equal to minus y upon determinant of minus 5220. Here we will use Cramer's rule. Then z upon determinant of minus 5224, okay, is equal to k. Now we will find out x upon this determinant of, so x upon determinant of 0 minus 8, so minus 8, x upon minus 8 is equal to minus y upon 0 minus 4, so minus 4 is equal to z upon minus 20 minus 4, minus 20 minus 4, that is minus 5 minus 2, okay, minus 5 minus 2, that is minus 2, okay. So it will becomes 0 minus minus plus 4, this will be our 2 plus 4, and z upon, that is minus 20 minus minus plus 4 minus 16 is equal to k. So x is equal to minus 8k, minus y is equal to 4k, and z is equal to minus 16k. Okay. So here x is equal to minus 8k, y is equal to this. So x is equal to minus 8k, y is equal to minus 4k, and z is equal to minus 16k. So we'll get the first eigenvector x1 is equal to, it is multiple of, if I take 4k common, then I will get 2, 1, 4. Is the first eigenvector 2, 1, 4. x1 is the eigenvector corresponding to the eigenvalues lambda 1 is equal to 1. Okay, so exactly similar way we will find out for the lambda 2 is equal to 2. Okay, so put lambda 2 is equal to 2, or lambda 2 is equal to 2, we will get, so 4 minus 2, just put it in the equation star. So 4 minus 2, 2. We'll get the matrix 2, 2 minus 2, 2 minus 2. Okay, minus 5, 3 minus lambda. So minus 5, 3 minus 2, minus 5, 3 minus 2 is 1, and 2, minus 2, 4, 1 minus 2, minus 2, 4, 1 minus 2, minus 1, into x, y, z. Okay, so minus 2, 4, minus 1. So we will get x upon, okay, exactly similar way we can calculate here. I'm directly writing here. So your system of equations becomes, with the help of this, is equal to 0, 0, 0. Okay. So here is 2x plus 2y minus 2z is equal to 0, minus 5x plus y plus 2z is equal to 0, minus 2x plus 4y minus 2z, sorry, minus z is equal to 0. Okay. Now once you are getting this, then we can calculate by using Cramer's rule. X upon, I'm taking these two equations, so 1 4 2 minus 1 is equal to minus y upon minus 5 minus 2 2 minus 1 is equal to z upon minus 5 1 minus 2 4 is equal to k. So x upon determinant of minus 1 minus 8, so minus 9 is equal to minus y upon plus 5 and minus of minus 4, that is 9 is equal to z upon 20 minus 2, 20 minus 20 plus 2, so minus 18 is equal to k. So you'll get x is equal to minus 9k, minus y is equal to 9k, and z is equal to minus 18k. So we will get x is equal to minus 9k, y is equal to minus 9k, and z is equal to minus 18k. Okay, so you will get eigenvector x2 is equal to, if we'll take minus 9k common, then it will give us 1 1 2. This is your eigenvector x2 for corresponding to the eigenvalues lambda 2 is equal to this. So x2 is equal to 1 1 2. Now x3, we will get x3 corresponding to the eigenvalues 5. Okay. Now see here, for lambda is equal to 5. So we'll get for lambda is equal to 5, 4 minus 5, that is minus 1, 2 minus 2, then minus 5, 3 minus 5, minus 2, 2, minus 2, 4, 1 minus 5, minus 4. Okay. So here you will get 1 minus 1, 2, 2, then minus 5 minus 2, 2, minus 2, 4, minus 4, okay, into x, y, z is equal to 0, 0, 0. Okay. So you will get system of equations minus x plus 2y minus 2z is equal to 0, minus 5x minus 2y plus 2z is equal to 0, minus 2x plus 4y minus 4z is equal to 0. Okay. Now, so you will get this equation. So solving by Cramer's rule. So x upon, I am taking these two. So minus 2, 2, 4 minus 4 minus y upon minus 5 minus 2 2 minus 4 z upon minus 5 minus 2 minus 2 4 is equal to k. Okay, so x upon determinant of this minus 2 into minus 4 plus 8 8 minus 8 0. Okay, is equal to minus y upon plus 20 and minus 4, so plus 24 is equal to z upon minus 20 and minus 4, so minus 24 is equal to k. Okay, so x is equal to 0k, y is equal to minus 24k, z is equal to minus 24k. Okay, so we will get x3 is the matrix corresponding to the eigenvalues. X3 is equal to 5. So here 0 1 1. I am taking 24k common. Okay, so this is the case where the asymmetric matrix is given and the eigenvalues are distinct. Okay, for non-repeated eigenvalues. Now we will see the case in this example. Now see, this is symmetric matrix. 3 minus 1 1, 3 minus 1 1, minus 1 1 minus 1 minus 1 5 minus 1 minus 1 1 5 minus 1. So this is a symmetric matrix. Okay, symmetric matrix. This is our symmetric matrix. Okay, now we will find out the matrix here. First of all, determinant of A, and after determinant of A we will get the eigenvalues. Okay, the characteristic equation is determinant of A minus lambda I is equal to 0. So determinant of 3 minus lambda minus 1 1 minus 1 5 minus lambda minus 1 1 minus 1 3 minus lambda, okay, is equal to 0. Okay, so we will get the characteristic equation is, we will find out the characteristic equation. First of all, we will calculate the determinant of A, S1, S2, S3 we will calculate. So what is our determinant of A is equal to 3 into 15 minus 1 minus of minus 1, it means plus 1, into bracket minus 3 minus minus plus 1 plus 1 into bracket 1 minus 5. So determinant of A is equal to 3 into 15 minus 1, 14 into 3, 42, minus 3 plus 1 minus 2 minus 4. So 42 minus 2, 40, 40. So determinant of A is equal to 36. Okay, we similarly you can calculate S1 is equal to, yeah, S1 is equal to, we can get A11 plus A22 plus A33 11. So S2 is equal to determinant of 5 minus 1 minus 1 3 plus determinant of P1 1 3 plus determinant of 3 minus 1 minus 1 5. Okay, so determinant S2 you will get, S2 is equal to 8 minus 1 7, so 15 minus 1 14 plus 9 minus 1 8 plus 15 minus 1 14, again 36. So S2 is also 36. Okay, so S2 36. So you will get S1 and S2 and determinant of A. So characteristic equation is, therefore the characteristic equation is Therefore, characteristic equation is lambda cube minus s1 lambda square minus s plus s2 lambda minus determinant of A is equal to 0. Okay. So lambda cube minus s1. S1 is given 11 plus s2. S2 is 36 minus determinant of A is again 36. So is equal to 0. So first we will find out the first root of the equation. So we can put 2. 8 minus, I'm putting 2 because 1 obviously not there. So 2 cube is 8, 2 square is 4, 11 into 4, 44 plus 72 minus 36. So minus 36, 72 plus 8, 80 minus 36 plus minus 44, 80 is equal to 0. Therefore, lambda is equal to 2 is the first root. Okay. Lambda is equal to 2 is the first root. So applying the synthetic division, we will apply synthetic division. Here is 2, 1, minus 1, sorry, minus 11, 36 and minus 36. So here is equal to 1, 2 into 1, 2, minus 9 into 2, 18, minus 18, 36, it means plus 18, so 36. If you are not getting here is 0, so suppose you are wrong somewhere. Okay, so here our roots are lambda minus 2 is the factor, lambda square minus 9 lambda plus 18 is equal to 0. Okay, so lambda square, lambda minus 2. So lambda minus 2 into lambda minus 6 into lambda minus 3 is equal to 0. Okay, so what are the roots of these characteristic equations? So lambda is equal to 2. We will assume that lambda 1 is equal to 2, lambda 2 is equal to 3 and lambda 3 is equal to 6. Okay, so again we will calculate the characteristic, again we will calculate by using same method the eigenvectors. Okay, so a minus lambda I into x, consider, is equal to 0, p minus lambda. Okay, here we will get 3 minus lambda minus 1 1, then minus 1 5 minus lambda and minus 1 1 minus 1 3 minus lambda 2xyz is equal to 0 0 0. Okay, now once you get it is 0 0 0, so put the value of for lambda 1 is equal to 2. Okay, for lambda 1 is equal to 2, we will get the system of equations 3 minus 2 1 minus 1 1 minus 1 5 minus 2 3 minus 1 1 minus 1 3 minus 2 1. Okay, so you'll get system of equations x minus y plus z is equal to 0 minus x plus 3y minus z is equal to 0, x minus y plus z is equal to 0. Okay, now we'll use the Cramer's rule. So x upon Here you will get 3 minus 1 minus 1 1 minus y upon minus 1 1 minus 1 1 is equal to z upon minus 1 1 3 minus 1 is equal to k. Okay, so x upon determinant of this, so which implies x upon determinant of 3 minus 1, that is 2, is equal to minus y upon minus 1 minus of minus 1, so plus 1, so 0. You will get it is 0. Okay, x upon minus 1 and minus of minus 1, so plus 1. So what is your matrix here? X plus y plus 0 z. After putting lambda is 1 is equal to 2, you will get 1 only. So y minus x minus y plus z and minus x plus 3y minus z is equal to 0. Okay. So minus y upon minus 1 1 minus 1 1. So minus 1 minus, so y is upon 0 is equal to z upon minus 1 and plus 1 minus 3, so minus 2, z upon minus 2 is equal to k. So x is equal to 2k, y is equal to 0k, okay, and z is equal to minus 2k. So you will get the eigenvector x1. Directly I am writing here x1 is equal to, if I take 2k common, so 1 0 minus 1, okay, is the eigenvector 1 0 minus 1. Now next is for lambda 2 is equal to, now I am telling this is our star, so put the values in a star, put the values of lambda in a star matrix. Okay, so for lambda 2 is equal to 3, for lambda 2 is equal to 3. Okay, so for lambda 2 is equal to 3, we will get 3 minus 3 0, 0 minus 1 1, 0 minus 1 1, then minus 1 2 minus 1, minus 1 2 minus 1, 1 minus 1 1, 1 minus 1 1. Okay, now we can find out for lambda 2 is equal to 3. So here is x y z 0 0 0. So 0x minus y plus z is equal to 0, minus x plus 2y minus z is equal to 0, x minus y plus z is equal to 0. Okay, so by using Cramer's rule, x upon determinant of 2 minus 1 minus 2 minus 1 1 is equal to minus y upon minus 1 1 minus 1 1 is equal to z upon determinant of minus 1 1 2 minus 1 is equal to k. Okay, so x upon determinant of 2 minus 1, that is 1, minus y upon minus 1, minus 1 is plus 1, so 0 is equal to minus y upon minus 1 1 minus 1 1. Okay, so is equal to 0 is equal to z upon minus 1 1 1 minus 2 minus 1, so is equal to k. Okay, so x is equal to k, y is equal to 0k, and z is equal to minus 1. So here you will get 0, the 3 minus 3 0, 5 minus 3 2, and 3 minus 3 0. So here is 0 z, so we will draw somewhere. X upon 2 0. Okay, so here is 0 plus minus 1 minus y upon 1 minus 1 minus 1 0. So 0 minus of minus 1, so plus 1, z upon minus 1. Okay, so you will get x2 is equal, x is equal to minus k, y is equal to minus y is equal to k, minus y is equal to k, z is equal to minus k, z is equal to minus k. Okay, so minus k minus y is equal to k, so x2 is equal to, we will get minus 1, here y is equal to minus k, so again minus 1, and z is equal to minus. So if I take one common, so you will get 1 1 1 matrix. Okay, so x2 is the 1 1 1 matrix. Now for eigenvalue lambda, now see all the values are covered. For lambda 1 is equal to 2, for lambda 2 is equal to 3, and for lambda 3 is equal to 6. Okay, for lambda 3 is equal to 6. So your vector becomes star 3 minus 6 is minus 3. Minus 3 minus 1 1, minus 3 minus 1 1 minus 1, 5 minus 6 minus 1 minus 1, 1 minus 1, 3 minus 6 minus 3. Here 1 minus 1 minus 3. X, Y, Z is equal to 0, 0, 0. Okay. So minus 3x minus y plus z is equal to 0. Minus x minus y minus z is equal to 0. X minus y minus 3z is equal to 0. So we can calculate x upon determinant of minus 1 minus 1 minus 1 minus 3 minus y upon, here is determinant of minus 1 1 minus 1 minus 3 z upon determinant of minus 1 minus 1 1 minus 1 is equal to k. Okay, so x upon determinant of minus 3, I'm writing here, x upon determinant of minus 3 plus 3 and minus 1, so 2 is equal to minus y upon plus 3 plus 1, 4 is equal to z upon plus 1 and plus 1. So 2 is equal to k. So x is equal to 2k, y is equal to minus 4k, and z is equal to 2k. Okay. So x is equal to 2k, y is equal to minus 4k, z is equal to 2k. So our eigenvector x3 is, if I take 2k common, then it is 1 minus 2, 1. 1 minus 2, 1. This is our eigenvector when the matrix is symmetric and eigenvalues are non-repeated. Okay. Now we will see the next example. Now find the eigenvalues and eigenvectors. We find the eigenvalues and eigenvectors where the matrix is asymmetric. So we will see when the matrix is asymmetric how to find out the eigenvalues and eigenvectors and see what are the eigenvalues are here. Okay, so for that first we require, for the characteristic equation we require determinant of A. So we will calculate determinant of A. Minus 2 into bracket 0 minus of here 12 minus 2 into bracket 0 minus plus 6 minus 3 into bracket minus 4 minus minus 4 minus of minus 1, it means plus 1. Okay, so minus 2 into minus 12 plus 24 minus 6 into minus 12 minus 2 plus 12 minus 4 and plus 1. So minus 3 into plus minus 3 into minus 3, 9 plus 9. So you will get determinant of A. Here determinant of A is equal to 9 plus 2, 6 and 2 plus 1. So here you will get 9, 4 plus 2, 8, 7. Somewhere is wrong. So you will get determinant is minus 24, 2 into minus 6. So here is plus 12, minus 3 into minus 3. So plus 9. So you will get 45. Determinant is 45. Okay. So determinant of A is equal to 45. Similarly, we will calculate S1. Minus 2 plus 1, 0. So minus 1. S2 is equal to determinant of 1 minus 6 minus 2, 0 plus determinant of minus 2 minus 3 minus 1, 0 plus determinant of minus 2, 2, 2, 1, 0 minus 12, 0 minus 3 plus 2 minus 4 minus 6. So here you will get minus 12. S2 is equal to minus 21. Okay, so each and every value is covered here. So we will get the characteristic equation of this matrix is characteristic equation of the given matrix is characteristic equation of the given matrix is lambda cube minus s1 lambda square plus S2 lambda minus determinant of A is equal to 0. So lambda cube minus S1, value of S1 is minus 1, minus plus lambda square. Okay, so value of S2 is minus 21 lambda and minus 45 is equal to 0. So minus 3 is the first root. Okay, we will put lambda is equal to minus 3, then we will get 0. Minus 3 cube is minus 27 and plus 9 minus plus 63 and minus 45 is equal to 0. So lambda is equal to 3 is the first root of this characteristic equation. So lambda is equal to 3 is the first root of the characteristic equation. Okay. So we will use the synthetic division to find out the other roots. Here lambda is equal to 3. So 1, 1 minus 21 minus 45. So keep 1 as it is. 1 into 3, 3. 3 plus 1, 4. So here is 12 minus 21 plus 2. So 9 minus 21. Here minus 3. So lambda is equal to minus 3 is the root. So here we will get minus 3. So here is 2. Okay. So minus 3 into minus 2. Here you will get plus 6. So here is minus 15 plus 40. Okay. Lambda is equal to minus 3 is the first root. So the roots are lambda plus 3 into lambda plus 2 into lambda square minus 2 lambda minus 15 is equal to 0. So the characteristic roots are lambda plus 3 into lambda square minus 2 lambda minus 15. So we will get lambda square minus 5 lambda plus 3 lambda minus 15 is equal to 0. Lambda plus 3 into, here you will get lambda minus 5 and into lambda plus 3. Okay, so is equal to 0. So lambda is equal to 5 and minus 3 and minus 3. Now here is the case where the roots of this characteristic equations are repeated. Okay, roots of the characteristic equations are repeated. Now once we are getting the characteristic roots are repeated, then lambda is equal to 5 minus 3 minus 3. So we will get here, we will find out for lambda is equal to eigenvector for lambda 1 is equal to 5. Okay, so the lambda minus a minus lambda I into x is equal to 0. Okay, so we will calculate a minus lambda I. So our a minus lambda I is minus 2 minus lambda, 2 minus 3, 2 1 minus lambda and minus 6, and here is minus 1 minus 2 minus lambda. Okay, of x y z equal to 0 0 0. Now here you will get for lambda 1 is equal to 5. So for lambda 1 is equal to 5, minus 2 minus 5 minus 7, 2 minus 3 2, 1 minus 5 is minus 4 and minus 6, minus 1 minus 2 minus 5 equal to 0, 0, 0. Good. So you will get the equations minus 7x plus 2y minus 3z is equal to 0, 2x minus 4y minus 6z is equal to 0, minus x plus minus 2y minus 5z is equal to 0. Okay. So by using Cramer's rule, we can find out the roots. So x upon minus 4 minus 6 minus 2 minus 5 equal to minus y upon 2 minus 1 minus 6 minus 5 is equal to z upon 2 minus 4 minus 1 minus 2. Okay. So x upon determinant of this 20 minus of minus 12. So 8, x upon 8 we'll get. So which is equal to minus y upon minus 10 and plus 6. So 4 is equal to z upon minus 4 and minus 4. So here is 8 minus 8 is equal to k. Huh? So x upon 8k, x is equal to 8k, y is equal to minus 4k and z is equal to minus 8k. So for this eigenvector x1 is equal to, for this eigenvector x1 is equal to, if I take 4k common, then you will get 1 raised to minus 10 and minus 6, so minus 16 here. Okay, so y is equal to plus 16. Y is equal to plus 16. Hmm? So if I take 8 common, so 1, 2, 1, 8k common. So x1 is the eigenvector for the non-repeated eigenvalue. Now for the repeated eigenvalue, what we will do for the repeated eigenvalue? So we will follow the same process and see. Now this is a symmetric matrix. Now for lambda 2 is equal to lambda 3 is equal to minus 3, we will get here the matrix minus 2 minus of minus 3, so plus 1 we will get here, plus 1 plus 1 2 minus 3 and 2 4 minus 6. So next minus 1 minus 2 and plus 3, minus 1 minus 2 plus 3. Okay, now see, this is our, now if you observe, this is our asymmetric matrix and see our chart here. What is our chart? See, if the rank of repeated eigenvalues, the matrix is repeated eigenvalues, and find the rank of A minus lambda I, that is Rn minus R eigenvectors are possible. Okay, so first we will find out the rank of the given matrix. Whenever the eigenvalues are repeated, so for if only one, that we will find out. If one only, find it. and if 2, so we will find. Now see. Okay, or lambda 2 and lambda 3 is equal to. So operate, we will find out rank for this. So operate R2 minus 2R1 and R3 plus R1. Okay, so we will get rank 2 minus 3. Here 2 4 minus 6 minus 2 4 minus 6 minus minus plus. So 0 0 0. Okay, so we will get here 0 0 0. Now R3 plus R1, just plus R1. So R3 plus R1, here is 1 minus 1 0, 2 minus 2 0, minus 3 plus 0. Okay, so rank of this matrix is R is equal to 3 minus 2, that is 1. So rank of this matrix is 1. Now if rank is equal to R, then there are n minus R possible vectors. So 3 minus 1, that is 2 eigenvectors are possible. Okay, 2 eigenvectors are possible. So put here A is a symmetric matrix. Here A is a symmetric matrix. Okay, here A is a symmetric matrix. Therefore we have x plus, we will consider for this. Now see, x plus 2y minus 3z. X plus 2y minus 3z is equal to 0. So from this matrix, put z is equal to 0. Put z is equal to 0. We get x is equal to minus 2y. Okay, and put y is equal to 0. So you will get x is equal to, so x plus 2y is equal to 0. Okay, so put z is equal to 0. So x is equal to minus 2y. So whenever we put, so we will get the matrix x1, x2 here. X1 is already find out. So x2 is equal to this. X is equal to minus 2y. Z is 0. If I put y is equal to 1, x is equal to minus 2. So this is our eigenvector. Okay. Now for y, put y is equal to 0. So we'll get x minus 3z is equal to 0. So which implies x is equal to 3z. Now therefore x3 is equal to, for repeated eigenvalues के लिए कर रहे हैं हम लोग. So put y is equal to 0 and z is equal to 1. If I put, then x is equal to 3. So this is the eigenvector. Okay. So this is the eigenvector. X3 is equal to 3 0 1 is the eigenvector. So x3 is equal to 3 0 1. Now this is the case where the matrix is asymmetric and the eigenvalues are repeated. How to find out the eigenvectors? Okay. Now we will see the next example. Now see, this is our symmetric matrix. Here A is symmetric. Why? Because row entry and column entry are same. 3 1 1, 1 3 minus 1, 1 3 minus 1. Okay. Here A is a symmetric matrix. Now once we got A is a symmetric matrix, then first step is to calculate the characteristic equation and eigenvalues first. So calculate determinant of A. So 3 into 9 minus of minus 1 is minus 1, minus 1 into 3 minus of minus 1, that is plus 1, plus 1 into minus 1 minus 3. 9 minus 1, 8, 8 into 3, 24, minus 3 plus 1, 4, 4 into minus 1, 4, minus 1 minus 3 minus 4. So 24 minus 4 minus 4, so you will get 16. So determinant of A is equal to 16. Okay, so here we are getting determinant of A is equal to 16. Now calculate S1. So here you will get S1 is equal to 3 plus 3 plus 3, that is 9. Similarly, calculate S2. S2 is equal to determinant of 3 minus 1 minus 1 3 plus determinant of 3 1 1 3 plus determinant of 3 1 1 3, which is equal to 9 minus 1, so 8 plus 9 minus 1 8 plus 9 minus 1 8, so it is 24. S2 is equal to 24. We got S1 S2 and determinant of A. Directly we can write down here characteristic equation. So characteristic equation is lambda cube minus S1 lambda square minus S2 lambda plus S2 lambda minus determinant of A is equal to 0. So your characteristic equation is lambda cube minus S1 is 9 lambda square plus S2 is 24 lambda minus determinant of A is 16. Minus 16 is equal to 0. Okay, so determinant of A is equal to this. So minus 16 is equal to 0. Now we can calculate the characteristic here. We will calculate the characteristic equation is here. So we can find out roots of this characteristic equation by using synthetic division. Okay, so we will use the synthetic division. See, so synthetic division we can do. So 1 is the first root of this characteristic equation. So we can apply the synthetic division over here. So 1 minus 9, 24 and minus 16. Okay, 1 into 1 minus 8 into 1 minus 8. So plus 16 into plus 16 means 0. Okay, so the roots are lambda minus 1 is the factor, lambda square minus 8 lambda plus 16 is equal to 0. Okay, so you will get the roots are here lambda minus 1 into lambda minus 4 bracket square is equal to 0. So lambda is equal to 1 and lambda is equal to 4 and lambda 1 is equal to 1, lambda 2 is equal to 4, lambda 3 is also 4. Lambda 3 is equal to 4. Now 4 is the repeated root. Okay. So lambda 3 is equal to 4. Now 1, 4, 4 are the, now here the matrix is symmetric and roots are eigenvalues are repeated. So how we can calculate the when the matrix is symmetric and eigenvalues are repeated. So for the non-repeated eigenvalue we can calculate the same way. So consider a minus lambda I is equal to 0. Lambda I into x is equal to 0. So a minus lambda I. So we will get a minus lambda I is 3 minus lambda 1 1 1 1, then 1 3 minus lambda 1 minus 1, here is minus 1, here 1 minus 1 3 minus lambda of x y z is equal to 0 0 0. Okay, so this is our matrix. Now put for lambda is equal to 1. We will get for lambda is equal to 1, lambda 1 is equal to 1. We'll get the matrix here 2 1 1 2 1 1, then 1 2 minus 1 1 2 minus 1, and last 1 minus 1 2 1 minus 1 2. Okay, here is xyz is equal to 0 0 0, right? So here you will get 2x plus y plus z is equal to 0, x plus 2y minus z is equal to 0. Okay, so here x minus y plus 2z is equal to 0, right? Now by using Cramer's rule we can calculate x. X is 2 minus 1 minus 1 2 minus y upon determinant of 1 1 minus 1 2 is equal to z upon determinant of 1 2 1 minus 1 is equal to k. Okay, now here x upon 4 minus 4 minus 1, that is 3, is equal to minus y upon 2 plus 1, that is 3, is equal to z upon minus 1 minus 2 minus 3 is equal to k. So x is equal to 3k, y is equal to minus 3k, and z is equal to minus 3k. Now if I take minus 3k, 3k is common, or minus 3k is common, then your eigenvector is 1 minus 1 1 1. Okay, this is the first eigenvector. Now this is the different case where the eigenvalues are repeated and the matrix is symmetric. Okay, so we will see that chart. At that time we have to calculate the A transpose, matrix of A transpose. Okay, so for the eigenvalue lambda 2 is equal to lambda 3 is equal to 4. Now for lambda 2 is equal to lambda 3 is equal to 4, we will consider first the matrix in this form. So you will get minus 1 1 1. Now see here, 4 minus lambda 3 minus 4 1 1 minus 1 1 1 1 minus 1 minus 1 1 minus 1 minus 1. Okay, and 1 minus 1 minus 1. Now we will find out rank of this matrix. So operate, okay, operate R2 plus R1, R3 plus R1. Okay, so you will get minus 1 1 1. Now R2 plus R1 minus 1 plus 1 0. Here is 0, here is 0, here is 0, here is 0, here is 0. So rank of this matrix R is equal to 3 minus 2, that is 1. So R is equal to 1. So here there are n minus r vectors are possible. N minus r vectors are possible. Okay, n minus r vectors are possible. So here n is equal to 3 unknowns, 3 minus 1. So 2 vectors are possible. 2 eigenvectors are possible. Okay, so here for that we have to assume that here the matrix is symmetric. Therefore the eigenvectors are orthogonal. Here matrix is symmetric. Therefore eigenvectors are orthogonal. The eigenvectors are orthogonal. Okay, therefore eigenvectors are orthogonal. It means we have, from this matrix we get minus x plus y plus z. See here, minus x plus y plus z is equal to 0. Minus x plus y plus z is equal to 0. Okay, now what we will do, put z is equal to 0. Put z is equal to 0. So we get minus x plus y is equal to 0, which implies minus x is equal to minus y, which implies x is equal to y. So for this your eigenvector is z0 1 1. Okay, so eigenvector is x2 is equal to 1 1 0. Now we have to consider for the symmetric eigenvalues. So for the symmetric matrix, eigenvalues are repeated. So we have to consider the eigenvector x3 is equal to LMN transpose. Okay. So x3 is equal to element transpose, which is equal to LMN. Okay. Now we will consider, and hence we will get, therefore x1 into x3 transpose is equal to 0, and x2 into x3 transpose x2 into x3 transpose is equal to 0. Okay, so hence the eigenvectors are x1 is here. We already calculated x1. x1 is 1 minus 1 1 1, x3 transpose is here LMN, so you will get here x3 is equal to, here x3 is equal to LMN and x3 transpose is LM, and transpose of x3 is LMN. Okay, so here minus L plus M plus N, you will get one equation which is equal to 0. Okay, now for x2 and x3 transpose, so x2 is 110, x2 into x3 transpose 110 LMN. So from this you will get L plus M plus 0n is equal to 0. So this is our equation number 2. This is our equation number 1. Okay. So from this 2, minus L plus M plus N is equal to 0 and L plus M is equal to 0. So which implies L is equal to minus M. From this we'll get L is equal to minus M. Okay. So once you get and put M is equal to K. So you will get L is equal to minus K. Okay, and m is equal to n is equal to L minus m, so you will get minus k minus k minus 2k. Okay, mk L minus k n minus 2k. So your matrix x3 becomes minus k Lm minus 2k and n is minus, sorry, here L is minus k, M is k and minus 2k. Okay, if I take k common, minus k common, then I will get 1 minus 1 2. So your matrix x3 is 1 minus 1 2. So whenever the repeated eigenvalues are given, how to find out the eigenvector? It is clear to you how to find out the eigenvector when the repeated eigenvalues are given to you. Okay, so obviously we will find out the repeated eigenvalues. How to find out the repeated eigenvalues? Now I think everything is covered to you here. Okay, now see next one, that is our next point, that is Cayley-Hamilton theorem. What you mean by Cayley-Hamilton theorem? Every square matrix satisfies its own characteristic equation. This is very, very important. Every square matrix satisfies its own characteristic equation. This theorem is known as Cayley-Hamilton theorem. Now square matrix, it means number of rows and number of columns are same. Okay. So every square matrix satisfies its own characteristic equation. Now we will see the first example, verify Cayley-Hamilton theorem. Now it's a very simple to verify the Cayley-Hamilton theorem here. Okay, so verify Cayley-Hamilton theorem. It satisfies its own characteristic polynomial, then definitely the Cayley-Hamilton theorem is verified. Okay, so first for that we have to calculate the determinant of A. So here determinant of A is equal to 2 into bracket 2 into 2 4 minus of 1 minus plus 1 minus 2 minus of minus 1 plus 1 into 1 minus 2. So 4 minus 1 3, 3 into 2 6 plus minus of minus 1 plus 1 minus 2 and plus 1 minus 1 into 1 minus 1. Okay, 1 minus 2 minus 1 minus 1 into 1 minus 1. 6 minus 2 is 4. So determinant of A is equal to 4. Okay. Here determinant of A is equal to 4. So once you get the determinant of A, calculate S1. S1 is equal to 2 plus 2 plus 2, that is 6. S2 is equal to determinant of 2 minus 1 minus 1 2 plus determinant of 2 1 1 2 plus determinant of 2 minus 1 minus 1 2. 4 minus 1 3, 4 minus 1 3 plus 4 minus 1 3. So it is 9. Okay. So determinant of A is equal to 4, S1 is equal to 6, and here is 9. So characteristic equation is characteristic equation is lambda cube minus s1 lambda square plus s2 lambda minus determinant of A is equal to 0. So lambda cube minus, what is our s1? S1 is 6, s2 is 9, 9 lambda minus determinant of A is 4. So lambda cube minus 6 lambda square plus 9 lambda minus 4 is equal to 0. Okay. So this is your characteristic equation. Now what we have to show that? To prove that it is a Cayley-Hamilton theorem. So it means we have to prove that this equation also satisfies the characteristic equation. Every square matrix satisfies this characteristic equation. So that matrix is also satisfies this. It means if I put lambda is equal to A, then it will gives you 0. That we have to find out. Okay. So we will calculate. We have to show that. Okay. So now we have to verify Cayley-Hamilton theorem. To verify Cayley-Hamilton theorem, we write this characteristic equation are a cube minus 6a square plus 9a minus 4i, which is identity matrix, is equal to 0. Okay. If we are getting is equal to right hand side is equal to 0, then definitely that square matrix satisfies its own characteristic polynomial. Okay. So A is given. We will calculate A cube. So A cube is equal to A square. So for that we require A square. Okay. So we'll calculate A square. A into A. 2 minus 1 1. 2 minus 1 1. Minus 1 2 minus 1. Minus 1 2 minus 1. Then 1 minus 1 2. 1 minus 1 2. Okay. So A square, calculate A square. 2 minus 1 1. Minus 1 2 minus 1. 1 minus 1 2. Okay. Which is equal to, we will get here. So A square is nothing but, after calculation you will get here 6 minus 5 5. Then minus 5 6 minus 5. Then 5 minus 5 6. Okay, this is our A square. So similarly we can calculate A cube. A cube is equal to A square into A. So which is equal to 6 minus 5 5. Then minus 5 6 minus 5. Then 5 minus 5 6. 5 minus 5 6. Okay, into A. Into A. A is given 2 minus 1 1. Okay. Now A is minus 1 2 minus 1. Then 1 minus 1 2. A cube is equal to this. So A cube is equal to, we will get 22 minus 21, 21 minus 21, 22 minus 21, 21 minus 21, 22. Okay, this is our A cube. Now put all the values A cube, A square here. See, that is we have to put A cube, A square, A and I. So try to get it is 0 or not. Okay. So consider. We will consider the characteristic equation here. I will write down in our next line. So your characteristic equation is A cube minus 6A square plus 9A minus 4I is equal to 0. Okay, we will check it whether we are getting on the right hand side is 0 or not. So just put all the values here. So you will get here A cube. So value of A cube is given 22 minus 21, 21. Minus 21, 22 minus 21. 21 minus 21, 22. Minus 6 into A square. So 6 into A square, after multiplying I am writing, or you can write here 6 into A square. So value of A square is here 6 minus 5, 5. Okay. Then minus 5, 6 minus 5. Minus 5, 6 minus 5. And then 5 minus 5, 6. 5 minus 5, 6. Okay. Now plus 9A. So 9 into A. Here 9 into A you will get value of A is given 2 minus 1, 1. 2 minus 1, 1. Then minus 1, 2 minus 1. Then 1 minus 1, 2. Okay. Minus 4 into identity matrix 1 0 0 0 1 0 0 0 1. Okay. Now check it is whether it is 0 0 getting 0 0 0 or not. Okay. So obviously you will get C 22 minus 36. So if I am multiplying here by 6 directly here, after multiplying by 6, here is 30 minus 30. Minus 30, it means here plus 30. Minus 6 into 5, again minus 30. Here plus 30. Here is minus 36. Here is plus 30. Here is minus 30. Here is plus 30. Here is minus 36. Okay, after multiplying by minus 6. You can check it. Okay. 22 plus 36 plus 9 into 2, 18 here. Minus 9 plus 9 minus 9, 18 minus 9, 9 minus 9, 18. Okay. Here 4. I'm multiplying only 4 with 4, 4, 4. So obviously you will get it 0 0 0, 22 plus 36. Okay. Here you will get minus 36. Here is minus 36. So here is minus 36 plus 18 minus 4, 1. Okay. So you will get here is 0. See. Not 1, 0, 0, 0, 0, 0, 0, 0, 0, 0. You can cross verify it. You will get all the values are C. Okay. So once it is satisfied, So by Cayley-Hamilton theorem, to find out the A inverse, what we will do, I will multiplying by A inverse throughout side. So what will happen? A inverse into A cube. So it will gives me A square minus 6 into A inverse into A square, 6A, plus 9A into A inverse, 9I, and minus 4 into A inverse is equal to 0. So which implies minus 4A inverse is equal to minus A square plus 6A minus 9I. Okay. So A inverse is equal to, which implies A inverse is equal to minus 1 by 4 into bracket, they are multiplying by minus sign, so A inverse is equal to 4A inverse. We will write here first, 4A inverse is equal to A square minus 6A plus 9I. A square minus 6A plus 9I. Okay. A square minus 6A plus 9I. So A inverse is equal to 1 by 4 into bracket A square minus 6A plus 9I. So now let's put the values of A square and 6A and 9I. You will get 1 by 4 into bracket. Value of A square is 6 minus 5, 5. Minus 5, 6 minus 5, 5 minus 5, 5 minus 5, 6. Minus 6 into A, 2 minus 1, 1. Then minus 1, 2 minus 1. Then 1 minus 1, 2. Plus 9 into identity matrix 1 0 0 0 1 0 0 1. So after doing this calculation, you will get A inverse is equal to, here I am writing A inverse is equal to, with the help of Cayley-Hamilton theorem, is 1 by 4 into bracket 3 1 minus 1 and minus 1 1 3 and 1 3 1. Here is entry 1 3 1 minus 1 1 3. This is your A inverse. Now as like we are getting the A inverse, similarly we will get A raised to 4 also. See, the question is given, find out also A raised to 4. So just multiply this characteristic equation by A. So you will get A raised to 4 is equal to C. So just transfer it here. So A raised to 4 you will get C. Here A raised to 4 you will get by multiplying both sides by A. So you will get A raised to 4 is, so A raised to 4 minus 6A cube plus 9A square minus 4A is equal to 0. Okay. So you can write A raised to 4 is equal to 6A cube minus 9A square plus 4A. Okay, just put the values of A cube, A square and A. So you will get A raised to 4. Value of A raised to 4. Okay. So A raised to 4 is equal to this. I hope you are clear the Cayley-Hamilton theorem also here. Okay. Now next one is a very simple way. Whatever we have studied, we will recover in these two example with the very simple manner. With a very simple manner, we can recover it here. See. So what do you mean by find out the, for a matrix A is equal to 5 0 1, 0 minus 2 0, 1 0 5. The two eigenvalues are 4 and 6. Find the third eigenvalue. It's a very simple. We know that the eigenvalues and our these values, see, we know that the property lambda 1 plus lambda 2 plus lambda 3 is equal to a11 plus a22 plus a33. Okay, the two values are given 4 and 6 suppose. So 4 plus 6 plus lambda 3 is equal to a11 is 5 A22 is minus 2, A33 is 5. So we can find out 10 plus lambda 3 is equal to 5 minus 2, 5 minus 2, 3 plus 5, so 8. So lambda 3 is equal to 8 minus 10, that is lambda 3 is equal to minus 2. So it's easily, so option number B. Okay. Okay, so we can easily find out the eigenvalue without doing any calculation, without doing any bulldozer method, जैसे हमने अभी सारे किए हैं. But yes, if the question asks for the engineering paper, engineering mathematics paper 1, then obviously you have to solve everything. But in a MCQs, if the question is asked for only 1 mark or 2 mark, then you can directly find out the eigenvalues with the help of these properties. Okay, so you must have to remember all these properties. How to find out the eigenvalues when the matrix is given and some other two values are given. Okay, now the next one is for the matrix A is equal to 2 1 1 1 2 1 0 0 1. The eigenvalues are, okay, so what are the eigenvalues? Okay, as we know that the eigenvalues are lambda 1 plus lambda 2 plus lambda 3 is equal to a11 plus a22 plus a33. Okay, but यहाँ पे बहुत सारे आइगन वैल्यूज दिए हैं. We have to select one the correct eigen values. Okay, so we will do trial and error method. Okay, so here a11 plus a22 plus a33 is equal to what? 2 plus 2 plus 1, that is 5. And also we know that the properties, the eigenvalues, the multiplication of the eigenvalues, you will get lambda 1 into lambda 2 into lambda 3 is equal to determinant of A. Okay, lambda 1 into lambda 2 into lambda 3 is equal to determinant of A. So first of all calculate the determinant of A. So you will get determinant of A is 2 minus 0 minus 1 into 1 minus 0 plus 1 into 0 minus 0. Okay, so 4 minus 1 plus 0. So here is 3. Determinant of A is equal to 3. Now we have to select the eigenvalues from the given option. Here determinant of A, here determinant of A is equal to 3. Okay, so here determinant of A is equal to 3 and the eigenvalues, sum of the eigenvalues is equal to 5. Now we will select the option where the multiplication is 3 and summation is 5. So see, if I take first option 2 plus 2 plus 1, so addition is 5, correct, but multiplication 2 into 2 into 1, no, there is no 5, there are no 3, multiplication is not 3, so this option is not correct. We will see second one. So 3 into 1, yes, it is 3. Determinant of A is equal to 3, we are getting. Now 3 plus 1, 5, yes, so this one is the correct option. Clear? So I hope you are clearly understand here how to calculate the eigenvalues and eigenvectors when the matrix is given with the help of this property without doing any calculation, as like our previous method, characteristic equation, then find out the characteristic equation, after that finding out the roots of that characteristic equation, and then we will find out the values. So without doing that, easily within a 1 minute you can calculate these eigenvalues and eigenvector with the help of these properties. Okay, so easily we can calculate these eigenvalues and eigenvectors with the help of these properties. I hope you are clearly understood each and everything, how to calculate about the eigenvalues and eigenvectors when the matrix A is given. Okay, so depending upon whether the matrix, this chart is very important. So to solve any example on the eigenvalues and eigenvector, this chart is very important. Now see, the first of all find out the characteristic roots of the equation, and if it is depending upon the roots of the equation, you will get the eigenvectors. If the roots are non-repeated and the matrix is asymmetric, then you will get, for the different eigenvalues you will get different eigenvectors. And if matrix is symmetric and the symmetric and roots are unrepeated, then also you will get the same. But matrix is symmetric and asymmetric and the roots are repeated, then you have to find out in this way. First of all, if the matrix is asymmetric, then use this one. If the matrix is symmetric, then use this one for the repeated eigenvalues. Okay, it's a very easy, simple techniques I have told you here in this exam lecture. So how to find out the eigenvalues? These properties are very, very important. Once you know these properties, then you can solve any example on eigenvalues and eigenvectors. Okay, if the eigenvalues are given, then how to find out the eigenvectors and everything. Okay, I hope you are clear here each and everything. So thank you for watching, and if you're liking my videos, so definitely do like, share and subscribe. Thank you so much. Tomorrow in the same time we will come with the most important topic from your GATE exam, that is differential equation, linear differential equation with constant coefficient. So keep watching and be present for the tomorrow's lecture.